So we're going to start with area between two curves. The area of a region that is bounded above by one curve, which would be this one, y equals f of x, and below by another would be y equals g of x, and then this line would be that function. The area is always positive, and if f and g are continuous functions on the interval a to b, and if f of x is greater than or equal to g of x for all x in a to b, then the area of the region bounded above by y equals f of x, below by y equals g of x, on the left by x equals a, and on the right by x equals b is this formula, which is area equals, and then your integral, so a to b, and then you have f of x minus g of x. F of x would be your top function, and then g of x would be your bottom function, and then dx, which is the derivative.
In this problem, I'm finding the equation to find the area between two curves, and it's just the setup. So this is f of x, this is g of x, and to find the bounds, which is what you have to do first, you have to set them equal to each other, which I do here, and the answer is x plus 2, x minus 2, so therefore the bounds are positive 2 and negative 2. And over here, the next step is to find which one is on the top and bottom, and to do that, you pick a number in between 2 and negative 2, and we pick 0 to make it easier. And when you plug those numbers in, g of x is larger than f of x, therefore g of x is the top, f of x is the bottom. And here, g of x is first minus f of x, and then d of x, and this is the...
So the next lesson is volume, and first one is the disk method. So this will be the steps that you should take in order to be doing the disk method. So first you're going to sketch the bounded region and the line of revolution, and you should make sure an edge of the region is on the line of revolution. Second, if the line of revolution is horizontal, the equations must be in y equals form, and if it's vertical, then the equations must be in x equals form. Then you're going to sketch a generic disk or a typical cross section, and then find the length of the radius and then the height of the generic disk, and then finally you're going to integrate with the following formula, which is volume equals pi times the integral from a to b, radius squared times the height.
In this problem, we're using the disk method to find the volume of the green highlighted area around the axis, which is y equals 4. So using these equations, we found the bounds, which are 3 and 0, and in this equation you have to have pi in front of the bounds. And we found the outside radius by subtracting what it's about 4 minus x, which is the diagonal, which is clearly on the outside. And then next one for the inside radius, we use 3, which is in here, and it's here. And that is the equation set up.
So the next lesson is volume, the washer method, and some of the steps in this are similar to the disk method. First, you're going to sketch the bounded region and the line of revolution. If the line of revolution is horizontal, the equations must be in y equals form. If vertical, the equations must be in x equals form. Then you're going to sketch a generic washer, and then find the length of the outer radius, which is the furthest curve from the rotation line, the length of the inner radius, the closest curve to the rotation line, and then the height of the generic washer. And then you're going to integrate with the following formula, which is volume equals pi times the integral from a to b, outer radius squared minus the inner radius squared times the height.
This problem is a washer method problem, and it's setup only. So using these equations, we have to put it in terms of y because it's revolving around x minus 2, as you can see here. So the first one we change to x equals 2 over y, and putting that into the outside radius, it's 2 over y minus negative 2, which is also like this because of the gap here, and it's a washer, so we have to do that for both of them. And this is the outside radius, this is the inside radius, and the outside radius goes first down here, so that's how we got this. And the bounds are on the x-axis, and you can see that it's 0 and 1.
So the final lesson is volume for cross sections, and you should know the following area formulas. So for a square, it's the side squared. For a rectangle, it's the side times the height. For a circle, it's pi times radius squared. For a triangle, it's half the side times the height. For a semicircle, it's pi times the side square over 8. And for an equilateral triangle, it's square root of 3 over 4 times the side squared. For cross sections of area A of x taken perpendicular to the x-axis, the formula will be volume equals the integral from a to b a of x dx. And then for cross sections of area A of y taken perpendicular to the y-axis, the formula would be volume equals the integral of a to b a of y dy.
Okay, so this problem's a cross sections problem. So find the volume of the solid whose base is bounded by y equals x plus 1 and y equals x squared minus 1. Cross sections perpendicular to the x-axis or squares. So first step in this one is to set the equations equal to each other to find the bounds, and once you do that you get 2 and negative 1, just shown over there. And since the cross sections are squares, it's s squared, and below that is the equations put inside top minus bottom, and you can see that here that x plus 1 is the top and x squared minus 1 is the bottom, and once you put them together, the result is right there.
Yeah. Okay, so this is AP problem 2009 number 4, and the problem reads, let R be the region in the first quadrant enclosed by the graphs y equals 2x, which is this line, and y equals x squared, which is this line. So part A is find the area of R. So as you can see, the bounds are 0 to 2, and you can see that the top function is y equals 2x, and the bottom function is y equals x squared. So you're going to set it up as area equals the integral from 0 to 2, 2x minus x squared dx, and then that turns into x squared minus 1 over 3 x to the third, and then 2 and 0 here because you're going to plug those two numbers in next, and you're going to get 4/3 as your answer. So part B reads, the region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals sine pi over 2x. Find the volume of the solid. So you're going to plug it into the volume formula. So you're going to have volume equals the integral of 0 to 2 sine pi times pi over 2x dx. Once you do the antiderivative of that, you'll get negative 2 over pi cosine pi over 2x, and then once again you have the 2 and the 0 because you're going to plug them in and then subtract, and then once you do that you should get 4 over pi as your answer. Part C reads, another solid has the same base R. For this solid, the cross sections perpendicular to the y-axis are squares. Write but do not evaluate an integral expression for the volume of the solid. So first, because you're on the y-axis, you have to put everything in terms of y. So this is going to change to y over 2, and this is going to change to the square root of y. So then also your bounds are going to change because you're dealing with the y-axis, so it's going to go from 0 to 4 instead of 0 to 2. So then your equation is going to read the volume equals the integral from 0 to 4 square root of y minus y over 2 squared dy.